hand or telemark. You'll note that I've set myself a very low bar. So some people are asking or saying that there should be no trivial JQ. I merely assert that there will be JQ, and some of it will not be trivial. So I imagine that you're mostly familiar with JQ. So well, certainly I'm assuming that you're familiar with JSON. JQ processes JSON. It takes JSON as input and it gives JSON as output. There are special cases to that, but we'll be talking only about that right now. So most of the JQ that I've seen ends up looking a little bit like this. So you have some big bit of JSON that you got perhaps from a REST API, and you just want some particular value from it, right? So you are, in this case, we're dereferencing, glossary.title, right? And that gives us the string example glossary. Now, there's an interesting thing to note here. That's a string, right? But it's a string in like literal quotes, like the first character of the string is a quote, right? That is to say, JSON always tries to output, JQ always tries to output JSON. This is, for example, the trivial JSON of one string. So, okay, of course, you can get back an entire array, and you can nest you can nest these references as deeply as you'd like. This is overwhelmingly the most popular use of JQ, I would say. You have some unreadable JSON coming back, perhaps as part of a REST API, and you just pipe it through dot, right? And that pretty prints it, right? So JSON by default always pretty prints its output. Okay, which leads us to the most basic operator. Well, it's technically filter in JQ. That is the dot operator. The dot operator accepts its input and outputs it completely unchanged. There we are. It does occasionally, it is useful for lots of things. Now, you'll notice that there are dots at the beginning of .foo and .bar, right? Those are completely different dots. The first dot is the identity operator. The second is just a joining, right? It's, a concatenation thing for dereferencing, right? Okay, so here's an example of something that you might want to do with JQ. We want to know all of the keys of the widget object, or I'm sorry, the widget element of the parent, the top object, and that outputs an array, right? Okay. Of course, we can nest the dereferences in the first part, right? So we are going down to widget.text and getting the keys of that, right? Okay, so let's do something that's a little bit less trivial. Sorry, so we want to find we want to return an array of those event handlers, right? The values of the on-click parameter, or not parameter, on-click key of the elements in the menu item array, right? Okay, so we go to the menu, right? We get that. So let's talk about subscripting. So you subscript just almost like JavaScript. So for simple subscripts, you can just use the bare word. For more complicated ones, you can use this kind of array notation like JavaScript with a string. Well, that is to say, you have to do that if it's something complicated, right? Okay, so now we have we're just going deeper in there. Now, this is the first time that things are starting to get a little bit interesting. So, menu item, as you see, has not returned JSON, or rather, it has returned 3 JSON. What is it? 3 JSON elements, I think is the word. I can't remember. It's not object, but well, these are 3 JSON objects. But you see that it's returned 3 of them. Okay. This is an array, and this has dereferenced that array, but sort of globally, right? It returns all of the elements of the array. So that is essentially a decomposition into a list. So yeah. Now, what's a list? So let's talk about that real quick. Lists are constructed with the comma operator. In Perl, we have no single operator that creates a list, right? In JQ, there is the one, right? So, but it's comma. So it's interesting. The input is commas, right? The output is just new lines. I've always found that slightly odd, but well, anyway. So okay. So we have, so at this point, we've dereferenced menu item. So why can't we use a dot at that point, right? That has always felt a little bit strange to me. Like I'm not quite, like I haven't quite put my finger on the rule that prevents it, right? But it doesn't work. So you either use dot and then a bare word, or you use braces and brackets and a string, and so now remember that first dot is still the identity filter. So okay, so we have dereferenced menu item into its globally, right? We're returning all three values at once, and now we are dereferencing the on-click element of that item. But which item, right? Well, it's all of them. So it just happens in parallel. Now, I don't know. I mean, I'm not sure if it's actually in parallel, right? But anyway, it certainly behaves in approximately that way. So anyway, that's just side by side. So we have on the left we have those three JSON objects, right? And on the right we have one element of each of the objects. We're almost there. So we're almost to our array, right? Our array of event handlers. So I said that JQ processes JSON, right? But that's actually a special case, and I guess I've alluded to this earlier. In fact, actually, JQ inputs lists of 0 or more JSON elements. And there we are, it is elements. I looked it up for the slide, but I couldn't remember. So lists of 0 or more JSON elements, right? And then it outputs 0 or more JSON elements. So JQ actually processes lists of JSON and outputs lists of JSON in parallel, right? So we had at this point an array, right? I'm sorry, no, a list of strings, right? Well, so we wanted an array. So here's the array constructor. So this is not an operator as such because it doesn't sit between things, right? And it's not a filter. So most things in JQ are filters. Things come in one side, so to speak, and come out the other. These array braces don't work that way. But it does take on the inside there, right? It has a list, right? The last thing that we saw was that menu item dot on click gave us a list, right? If you wrap that list in brackets, then you get these you get an array. Okay, so there we are. There's our constructor. Like I say, it's not a filter, right? All the examples so far have been filters. So this is our program that gives us all of those event handler the event handler strings, right? And what have we covered so far? Whoops, pardon me, wrong button. We've got the identity filter. We have subscripting, right, to arbitrary levels of nesting. We have the dereferencing to return all at once. We have the special case of subscripting all at once into the respective values. And we have an array constructor, right? So that's what we're going to do. So the question is whether it's too late to rename the talk. But anyway, so let's try to do some slightly less trivial JQ. So at this point, we want to find the broken column alias. What do I mean? So for a client of mine had a data warehousing tool that where the configuration of it was specified in JSON. Okay, so there were many JSON files. One of them was this one. Well, not this one. This one's ridiculous, but but it had a vaguely similar structure. So you can see in each case we have an object, right, representing a table. So we have Roman, right, and what Romans have are first names, last names, and nicknames, right. But they call them a praenomen, a nomen, and a cognomen, right. So those are the aliases. The province, right, has a name and a governor, but we'd like to call them a prefectus, right? So. And the legion doesn't actually have aliases, right? So we have to make sure that we handle all of that. So this one, skipping to the end here, that's the program that gives the output that I wanted. It skips over. Oh gosh, I don't have a slide with the output of this. So it skips over the elements, or that is to say the objects that where the aliases are all correct, and it does not barf on the one that does not even have any aliases, right? So, okay, so let's talk about what this program exposes. The first thing that it exposes is that it is a shebang script, right? And JQ can in fact run as a shebang script. So the really important thing is and that lets you it's much more readable, right? And you can use comments, right? So the important thing is that you have to use the -f switch. That is absolutely mandatory. It also means that you cannot use any other switches unless they can combine with -f, like -raf, right? For -r, -8, and -f, right? You cannot use any other switches. Why? So, well, I should not have put this here because I'll have to come back to it. So, may I digress? This was really weird. This was surprising to me because Perl is just fine with multiple command line switches in a shebang script, right? You can use, it's been a long time since I did Perl-W at the top of a script, right? You now use warnings, but you could have, right? And use like -s, I believe, for the really simple get-opt handling. You could put both of those at the top of your script, right? You cannot do that in JQ. Why? Because the way a shebang script is processed is this. The kernel notices that it begins with the magic characters, #bang. On some older systems, it had to be #bang // but and then the next space delimited string is the path to the interpreter. And then the next space delimited string is the single argument that it will pass. Okay, it will only pass the one argument. Incidentally, by the way, this also means that you cannot use shebang scripts with any interpreter that has a space anywhere in its parent, in any parent directory. No matter how you quote it, no matter how you / it, nothing. Right, which in turn makes it a little bit challenging to build Perl in a directory that is and in Windows, right? So, anyway, so let's say I have this program, shebang user bin JQ-f. So actually, here. I meant to do more of a slide on this, but let me just do this real quick. The program here is sum divided by length. In JQ, the inputs of each function are all the same at any particular point, right? Like within any particular two pairs of pipes, and I'll get to pipes in just a second. which is to say, sum divided by length is the average function, right? If you have an array of numbers, that array is passed to sum, that same array is passed to length, right? And then it divides. I just find that, I find that really fascinating. It's a really interesting, elegant aspect of JQ. Okay, so I run pretty programmed at JQ, right? It's a shebang script, giving it ugly data.json. Here's what happens. We get the kernel, it's as if we had typed this, right? The kernel, the kernel does user bin JQ-F, right? Because I put JQ-F in my shebang line. And then it passes the file name of the script as the first argument, and then whatever arguments come after that. Pardon me. So, like I say, that means that you cannot use two different command line switches if they have to be separated by a space, because the kernel is only going to read the first one. Actually, no, I'm sorry. My apologies. Earlier, I said that it parsed up to the next white space, right? The next space character. It doesn't. Actually, what it does is from the white space that terminates the path to the interpreter until the very end of the line is all one argument. So, incidentally, by the way, that's how Perl, I believe, that's how Perl is able to be smart. It actually reads, never mind. It doesn't read that argument. Anyway, what Perl does is it reads the shebang line. It reparses the shebang line. Usually shebang scripts just ignore them. That's why they're comments, right? So that's why they begin with a hash. But anyway, so.
On the previous slide,
yeah.
You had sum over length. What is it summing? Is it summing just all the numbers in the JSON? Or?
So sum accepts an array as argument, and so does length. So
this is assuming that the JSON that's being tested is an array. So maybe you've done some filtering or something.
That's right. And if it were not, then it would error out.
Okay.
Yeah. Incidentally, so would length. So okay. Pardon. I'm sorry. I'm sorry. I can't hear you. Okay. So if I try to do this, it treats -a space -f as a single argument. Anyway, I found this fascinating, and so I should probably cut this digression short. But right, you can't. So the documentation to env mentions this, or at least in a recent version. The version that I have doesn't actually, and it mentions it because it has a workaround. But anyway, the workaround in core utils in the current version of Debian doesn't actually have that. But anyway, so. Okay, back where we were. We want to find what we want is the, pardon me, I'm sorry. What we want are the names of the tables and the offending columns, or that is to say the offending aliases, for any alias that does not point to a column, okay? But that's all we want. So, again, here's our program. Whoops. And first, let's talk about the pipe operator. The pipe operator is the most important thing in JQ, and it is not surfaced in the man page, right? The man pages for JQ are fucking impenetrable. They are really bad. The most important thing in JQ, the central concept is this pipe, okay? Everything comes in on the left, it comes out on the right, okay? And that's true for the functions between the pipes. So, for example, on the left we have, in the heading, on the left we have the identity operator, period, right? On the right we have keys, okay? So in the example, we have this array of objects, and what we're looking for are the keys of the second element of that array, right? So we pass it the second element of the array, and it gives us the keys. The important thing is this: this is how you pass functions in JQ. Okay, they do not. You do not have. You don't just append keys as if it were a method call, right? In this particular case, the second element of that array is an object, right? So you can attempt to dereference it with a string like keys, but you'll get nothing, right? You get null, right? If it were an array, then you'd get a runtime error. Everything happens via pipes, right? This is not an object-oriented language. It's a functional language-ish. So why not keys, right? With parentheses, right? Well, because that's just not how it works. That's just not how JQ does it. There are exceptions. They are rare, and they are weird. For example, in the newest version of JQ, there are a number of math functions like sign, right? And all of the math functions with one argument take their argument through this normal, well, let's not talk about this while I'm on the incorrect slide. They all take their argument through the normal way, right? Through the pipe. Wow. So all of the functions that have two or more arguments take them in through parentheses because there's no way to pass more than one argument at a time through the pipe. So it's a little bit awkward at times. But the most natural way for a JQ function to accept its arguments is through the pipe. So in this particular case, then, we see that there is no such function defined that called keys that takes one argument, which is what that keys/1 means in JQ error speak, which is the worst error message. Like the error messages are like 1998 tar level bad. So. Okay, so the next thing we'll talk about is we've talked about the pipe. There's a pipe equals. So pipe equals is interesting. Pipe equals is equivalent, well, I wish I'd actually written this down, I guess I didn't. Pipe equals is, well, anyway, is an update, right? So it accepts the input and then it evaluates the thing on the right and sends back the entire object with that change. So this is kind of strange. This is the first example of a situation where dot changes in my examples so far. So say that again? Where dot changes, right? Yeah. So yes, thank you. So we have here the same array of objects, and the only thing we're doing is saying that the first element's A element is changed to the string hello, right? But it returns the entire object. Hello, I wish I'd given a better example. Hello is an interesting expression in this case because hello is a literal, which is to say it is a function that ignores its inputs and outputs the word hello, or it outputs the string hello, right? Everything in JQ, well, okay, almost everything in JQ is a function in this way, okay? It has an input, it has outputs. Numeric literals are the same way. In this particular case, however, and I wish I'd come up with a better example now that I think about it, dot would have its own meaning. So dot would be the thing passed in. And I apologize that I'm not giving you a better example. The point is that you could, so I'm sending in the, the number 1, right? Because that is what is at the first element of the array, the A element of that object, right? That is the number 1. If I had said pipe equals dot plus 1, right? Then it would still return the whole object, but the whole object would be changed so that A was equal to 2 instead. Does that make sense? Dot is different on the left hand and on the right, and dot is always different on the left hand and on the right of a pipe. And the most important thing about programming in JQ is always knowing what dot means, right? Always knowing what it is that you're operating on at that particular moment. So, okay, now, Let's look at this. This is, what is it, the alternative operator. So the alternative operator is a little bit like Perl's OR operator. It is not similar to Perl's, I don't know what to call it, slash, right, tilted OR, defined OR operator. It is not similar to defined OR. It only checks truthiness, not like definedness or something like that. So let's talk, yeah, go ahead.
What is truth to JQ?
Indeed, yeah, actually, yeah, what is truth to JQ? Yes, so what is truth is is a very interesting question, and what is truth in JQ is a less interesting question in the sense that it's very disappointing, but I'll show you that in just a second. Unfortunately, I think I put that slide in kind of the wrong place. It should have been right here, I guess, right? But we'll get to that in just a second. So let's talk about the not function. So the not function is a really fine example of what I mean when I say that all JQ functions take in their inputs through the pipe, right? And their outputs go out through the other pipe or whatever, right? So I had a really hard time when I was first learning this not using, it's unfortunate. I had a really hard time avoiding trying to use not as a prefix operator or as a function, right? It just doesn't work that way in JQ, right? It's a function just like everything else, and it accepts a value and outputs either true or false depending on the truthiness. So in this particular case, I've made it slightly more complicated by using the comma, right, to return a list of Booleans. So, and you see that the integer 4 is apparently a true value, right, because it gets inverted to false, and the non-existent value at f is a falsy value that gets inverted into true. So now let's talk about select. Select is weird. There's lots of things in JQ are weird. In fact, it feels like walking on the moon or something. But select is one of the particularly weird ones, in my opinion. So select is strange in that it accepts input on through the pipe, right? Whoops, what did I do? Okay, input through the pipe, right, in the normal way, and through parameters. The way it works is this. When it is called, it gets one input, just like everything else, but with some functions, it's harder than others to remember that, right? Select is kind of one of those. It gets one input, and at that moment, it evaluates the thing inside of the parentheses, okay? Now, inside the parentheses, it has reset what dot means, okay? What dot means is the thing passed in on the left, okay? So what it does then is evaluate the thing in the parentheses for truthiness, okay? If what it gets is true, then it returns the thing that was passed in through the pipe, completely unchanged, okay? If it is false, it just doesn't, right? So, and the way in which it just doesn't is kind of odd. I apologize, I didn't get to the slide that I wanted to talk about this, though I really enjoy this slide. I would have enjoyed it a little bit more with information on it, but the title and the content somehow go together. So, okay, let me talk for a second about the empty value. Actually, no. Let me jump ahead and answer util's question first, because that's a little bit easier, and the empty value becomes easy to talk about after that. So here are all of the JSON data types. Okay, we have null and false, which I've separated out into their components. Right, it's just I'm sorry, that is to say true and false, which are obviously just Booleans. Right, we have null, which is a sui generis type. Right. We have various numbers, strings, arrays, and objects. Incidentally, by the way, JQ at least, and I believe this is true for JavaScript as well, does not have integers, okay? JQ certainly does not, right? It has 64-bit floating points, and that's what you got, right? So just remember that. So all numbers in JQ are true. All strings are true. All arrays are true. All objects are true. This includes the empty array. This includes the what would you call it, the object with no properties, okay? This includes the empty string. This includes the number 0, right? It surely includes the string 0 but true, right? Okay, so false is false, which, thank God. And null is false. Okay, those are the only two false values, okay? So let's talk about empty again. So we have these different types, okay? What is this? Including true and false is one Boolean. We have, what, 6, right? 4, 5, 6. So empty is its own type, and it is not mentioned in the docs, okay? So, or rather it kind of is. So there is a function called empty. It returns empty, makes sense, which is a little bit like returning nothing. In fact, it's a lot like returning nothing. But it is a return value. So, and again, I apologize. I meant to, I wanted to have time to actually have something to show you while I talked about this part. But empty is not true, and empty is not false. If you not empty, you get empty. Okay. Say again.
It's like null and SQL.
Yes. So it's an oddly infectious value. So select, okay? What select returns, if it does not return what it gets passed in unchanged, right? It returns empty, okay? Now, if you have an array that is 1, 2, 3, empty, 4, 5, you have an array 1, 2, 3, 4, 5, okay? It could be, I don't know, ham, eggs, empty, 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 and empty, right? And you get ham and eggs, right? So objects are different. If you have any object value that is empty, your object is empty. And that really drove me nuts on the particular script that I'm showing you right now, because what I really wanted to do was use select on each of those aliases, right? And somehow return the key and the value if it were if it were missing, basically, and not otherwise, right? But you can't do that. If you have any value in an object that is empty, then that object, the whole object, is empty. That drives me nuts. 1 plus empty is empty. Empty plus empty is empty. 1 double equal empty is empty. 1 bang equal empty is empty. So anyway, empty is an oddly infectious value. So thank you for listening to my rant, and I'm feeling very better. Okay, so map. Map is easy. You know what map is. But the odd thing is that, again, it takes in an input on the left, and it evaluates the thing in the middle, and then returns an array. Like, it does that for every element of the array it's passed, right? So it returns an array of those replacements, right? So in this particular case, though, we're using select, right? So we have the condition that select is using is .a, right? So map is being passed that whole array. Select is being passed in turn object 1 and object 2, or array subscript 0, array subscript 1, right? And then and that is dot at that moment, right? It then evaluates dot a. In the first case, dot a is 1, which is a truthy value, and it passes. And so select says, well, that is a truthy value, and it passes in what it was passed, which is to say the first element of the array, right? Fine. So there we are. In the case of the second element of the array, it does the same thing. It tries to dereference A. It gets undef, or I'm sorry, undef. Yeah. And I really am trying to learn Node too, I promise. Anyway, it gets null. Null is one of the two falsy values. Select says, in that case, I'm going to return empty. It's so odd. It doesn't like omit to do something, right? It returns an affirmative value. That affirmative value is empty. Anyway, yeah, we were talking about like what is truth, like, but in a JQ concept, like this is like what is existence, like in a JQ concept, right? So anyway, anyway, so and in that case, it's null, therefore false, therefore empty, and arrays flatten down to remove their empties. So, okay, with entries. With entries is neat. With entries turned out to be the way that this whole thing worked. So, remember I said that what I wanted to do, and I'll leave the code up in case it's legible enough to what I really wanted to do was somehow go through, so for each table, go through each alias, each column alias defined within that table, dereference it, right? Like, or you know what I mean? Like, see if there's a column of that name, and if not, because I'm looking for the broken ones, if not, pass it through, right? I wanted to use select, right? But you can't with objects because empties propagate up, right? So, with entries is neat. And in fact, actually, when I think about it, what I really wanted, what I really thought I was doing, or really thought I was going to trying to do, was somehow decomposing an object into like a bunch of Perl 6 pairs, right, or something like that, and then operating on like as if it were an array of pairs, right? So, well, as it turns out, that's what with entries does. So, with entries, it accepts an object on its input, and in the parentheses it has a replacement value, sort of like map. Okay. In fact, I thought I must have deleted that. Anyway, in fact, with entries is precisely to entries map from entries, and I apologize that I have to hand gesture it instead of it being on the slide. It should have been on the slide. So. With entries, like I say, is precisely to entries map from entries. So what does to entries? To entries accepts an object and returns an array, essentially of pairs, right? So it accepts an object and returns an array of objects. That array has as many elements as that object has properties, right? And each one is called key. Each one of those objects is key, and then anyway, yes. So and then you can iterate through those, and that's great. So that's what I ended up doing, right? You see, well, anyway, you see with entries. Pardon me. For each one of those pairs, I'm taking the value, okay, that is to say, the thing that the alias points to, okay? I'm running it through this function, which we'll get to in a second. And then that function returns, pardon me, one second. That function returns the set of broken aliases, okay? I don't actually want to return the tables that have all good aliases. I just want the broken aliases, right? So, so this with entries basically filters out the tables that either have all broken. That either have all working aliases or have no aliases at all. Okay, that's what that with entries is doing, right? So value has to exist and have a length of greater than 0. So, yeah. So now let's look at dot as variable. Now, that one I am having a really hard time explaining, and I stared at this for a very long time, and I apologize that this is what I have, but Remember how I said that you always have to know what dot is, okay? This gives you the opportunity to save dot at a particular stage in your pipeline and refer to it later. So in this particular case, for example, I am saving it. So in this particular case, bad aliases accepts one of the table definitions, right? That's sort of the top level object elements, right? It accepts one of the table definitions, and it stashes that away. Now, incidentally, in JQ, all variables have to begin with dollar signs, which actually I kind of love because I always, well, I mean, okay, I don't have to tell you why I love that. So, right. Anyway, it's just that I feel like I've got a really good philosophical reason to. Anyway, so I really do feel that way, and I'll bore you with it later. Thank you. So, okay, so dot sort of takes, as sort of stashes dot away into a variable, okay, in this particular case, table. The reason why I'm doing that here is because the next thing that I'm doing is going into the aliases, right? Now, at that moment, okay, or that is to say, by the time we get to keys, dot is just the aliases, right? The table's gone. Right? There's no way at that moment to get back up to the table, right? There's no way to climb up, right? There's like, it's not like some kind of like doubly linked tree or something, right? But what you can do is stash dot away into this variable table, and then I can use that later on to dereference table dot, well, the way it works is, it's, anyway, because it's all messed up, table dot structure dot, column name, right? So here I have, I've stashed away the table, and now I'm going into the column aliases, and by the way, if it's not defined, I'm saying just use an empty array. I'm getting, pardon me. Right, I'm getting all of the keys, and then going through them, making sure that they do not, right, properly reference a column. Okay, so that's what as does. Now, def. Def is kind of neat, and I was really agonizing on how I was going to explain def, and then I realized that there's no explanation at all necessary. Def is just a JQ program, right? So it's just any JQ program at all, right? So conceptually speaking, def is no more complicated than the script that it sits inside, right? It's got an input, it's got an output. Just remember the inputs come in on the left and the outputs come out on the right. It is actually possible to define a JQ function using def that has like parentheses style arguments also, and they also behave oddly. You do not pass values through there, you pass filters, right? It's like you're passing a code ref, okay, through those. Anyway, I apologize I don't have an example of it, but if you ever look into it, remember that arguments don't go in through the parentheses, right? And if they do, it's really weird and you'll have to think about it and read the docs. And now that you have seen around a little bit, it should be a little bit less impenetrable. So, oh, right, so there we are. Def is the easiest thing in the world, to explain. It's just a JQ function. So, and that is what I meant to do. Does anybody have any questions?
So, how long did it take you to figure this stuff out? And I have a follow-up to that, which is, so, at what point does it become better to learn this than to just write a Perl program that uses like JSON-encoded and does all this?
Right. I think that's a really good question, especially, okay, sorry, I'm trying to get into the habit of repeating the question into the microphone. So the question, and please correct me if I don't summarize this well, the question is, hey, it looks like JQ's a weird language, why wouldn't I just use Perl? And the answer is, I don't know, that's the answer, but I'll try to expand upon it a little bit. So, I mean, like in a way, I guess, because you don't have to do file I/O, right? But at this point, you don't have to read the file. But there are some really interesting, like some really powerful, what's it called? Functional methods that JQ provides, right? But you're right, it would be really, really easy to just iterate through, here, let me show, while I'm talking about this, let me show the data structure again, which I should have had another slide about that more recently than this. So, just iterate through call alias for, in each case, and make sure that like basically make sure that at least one fails, and right, that would have been really easy to write. You're right. Now, the reason why I say that's a really, really good question is because there are at least a few language implementations of JQ. Like there's JQ in Java, right? And there is, I can't remember what the other one was that I found. I think Python. There isn't one in Perl, maybe because why would so. And that's so that was actually a question I was wondering about. Like maybe I should write the JQ in Perl module, right? And then I'm trying to think like what is the difference between that and writing it in Perl? Anyway, I don't know. I mean, so in this particular case, I think it's neat. There are some situations where it really is a lot easier to do it in JQ. This case was not, but it also made it a really great example for my slide. So. Hi there.
I was going to follow up with what you were saying. I found it very useful, say, if you want to search through a bunch of JSON documents where you want to find everybody's name who lives in Minnesota. Quick one-liner, whereas if I had to do anything half as complicated as what he was just doing in Perl. Okay.
Right. Yeah. I mean, yes. So certainly, sorry? Oh, right. So yeah, and I think I think in a way that's what I was already going to do is say that certainly if your JQ program is really, if your JQ program is trivial, right, then it is a one-liner, where in Perl it would not be a one-liner, right? Like, I mean, even just iterating through, like give me all of the keys is not a one-liner in Perl. I mean, it's one-liner, but I mean, it's not 4 letters, right? So, Bruce?
As regular expressions are to strings, JQ is to JSON.
I'm not sure about that because it's just as easy for me to iterate through an array, and I don't know. I mean, I guess if my programming language of choice, here, let me back up for a second. In higher order Perl, right? Marchese and Dominus makes the case that Perl is an acceptable Lisp, right? It could just be that the language that I like is already has the functional, stuff that makes JQ neat, right? And if I were programming in C all day, well, okay, then yeah, let's use JQ instead. I'm sorry, I can't remember what I'm disagreeing with you on. Hi there.
Yeah, so it seems to me that previous job we were supporting lots of different versions of a JSON API, and we had to do things like transform things from one version to another version. But it seems like JQ could at least done some of them a lot more easily than having to do it like we were doing in Python.
Yeah.
But because it saves you having to do all the iteration and do this and do that, it seems like you do it in just a few lines of code.
Right. Yeah. Like I guess that is kind of a part. I'm sorry. What Walt said was that. I guess in a way I'm going to restate that. What Walt seems to be saying is that one of the things that that's neat about JQ is it's a little bit like every function has a little while loop wrapped around it, right? Because those pipes are like just everything that comes in, I do it and it goes out. And some of the pipes somehow multiply the output, right? For example, the wildcard dereferencing operator, right? Now you have, because remember, so a function, for example, like keys, okay? It doesn't take one array. It takes every array that it gets, right? One at a time. And some of these things produce, multiply the outputs, and now you're iterating over all of those at once, right? And that's kind of neat. One thing that would be especially interesting, actually, that would definitely answer the why JQ question is if it were particularly performant. If, for example, it was multiple core, and I have no idea, but that's something that I'd like to find out at some point. Any other questions? I think it's the last question. Yes. Oh.
Things I found really useful is manipulating Elasticsearch settings.
Can you say that again?
One of the things I've used this a lot for is manipulating Elasticsearch settings.
Okay, so
Use curl to dump it out, change the JSON, and then use curl to put it back.
interesting. Yeah, I apologize. I'm not familiar with Elasticsearch, but yes, I imagine that. So he was saying that JQ is very useful for manipulating Elasticsearch settings. I mean, like it sounds like it's basically a read, a manipulate, and a write back to the same thing, right? So yeah, I mean, like it's so. JQ like the manual describes itself, or maybe it's the web page, describes itself as like basically sed for JSON, right? And it is the case that the only sed command that I always consistently remember is S, right? And the only JQ command that I am sure to remember is dot, right? Like, dereference, right? And keys, right? So that's it, I think.